In this section, we're going to build a tilt switch. The tilt switch is going to look like this, where if it's flat, the LED is off, and when we tilt it, the LED lights up. To do this, we're going to have to introduce some new concepts. The first is the idea of a variable, and the second is using variables and if statements to make decisions in our program. Let's start with variables. Conceptually, I like to think of a variable like an empty cardboard box, and you can put lots of different things into a cardboard box. A stuffed puppy, a ball, a piece of paper with a name on it, or a number, or 42 paper clips. Boxes are kind of magical because you can put lots of different things into them. A variable is like that cardboard box, with the difference being that it's in the memory of your computer. In this case, we can store values into the memory, and the values can be anything from text to numbers, but there are lots of different things that we can put into the memory of our computer, just like we can store lots of different things into a cardboard box. In addition, there are lots of different types of things. Boxes are made in different shapes and sizes, depending on what you're going to put inside them. The same is true of memory variables. If I'm going to hold a piece of text, like somebody's name, I'm going to have a structure in the memory that looks different from if I'm holding a single number or a single 0 or 1. For the purposes of what we're doing today, we're going to narrow this down to just numeric variables, meaning variables that hold numbers. And we can narrow it down again because there are two kinds of numbers that we can hold. One is an integer or a whole number or a number that has no decimal places. And the other is a floating point number, which is a number that has decimal places or digits after the decimal place. To specify this, we're going to use the term int for integers and float for floating point numbers. We've learned that variables hold values and that there are different kinds or types of variables. We also need to know that every variable has to have a name. When you're ready to use your variable, or before you use your variable, you have to introduce it. I call it introduce. Most computer scientists would say this is defining the variable or declaring the variable. I like the term introduce because I think of it like I went to a party and somebody introduces me to their cousin, and they would say, "This is my cousin Steve." And I hear two things there. I hear the relationship or the kind of relationship that we're dealing with, and I also hear the name of the person. When we introduce variables, you're going to introduce the variable by saying this is the type of the variable and this is the name of the variable. An example here is int miles. Assume that I was building a program that does a miles per gallon calculation. I could say this is my integer and its name is miles, and I would do that with the quote that you see here, int miles. Or I could make a floating point number that's going to hold miles per gallon. This is my float, mpg. And we don't have to say this is my. You just give the type of the variable, int, float, and then you follow it with the name of the variable that you're going to use. If you wish, you can also give your variables values when you introduce them. In this case, to give a variable a value, we simply tack on an equal sign and the value that we want to put into it. So I'm saying integer miles is equal to 326. We've traveled 326 miles. Int gallons, we've used 10. And float mpg equals 32.6, which would be holding the 326 divided by 10. It's important to note that if I put the wrong kind of thing into the variable, I will get an error. As an example, if I said that we went 326.3 miles, the computer is going to yell at me when I compile the program and say, you built a floating point number and you tried to stick it into an integer. That's not allowed. In addition to giving variables values when you define them or when you introduce them, you can also give variables values or new values as your program is running. This first line would be defining the integer variable miles and setting it to 326. The second line would be taking the value 402 and putting it into miles. The way this works is that your variable is always on the left, and the value that you're going to put into the variable is always on the right. We can also use an equation to compute a new value for a variable. Here you can see that I'm putting the value 402 divided by 10 into MPG. The computer will take 402, divide it by 10, get the answer, and then the equal sign says make the thing on the left equal to what's on the right. This is interesting because if you see an equation like x is equal to x plus 1, if you were good at math, you might say, well, that's impossible. That equation could never happen because x can't be equal to itself plus something else. But in this case, what will always happen is that the computer will do the math on the right first and then take the resulting value and put it back into the variable on the left. So if x was 5, when we got to this line, the computer would say 5 plus 1 is 6, and then it would set x equal to 6. We can also compute values using variables themselves. So instead of saying MPG is equal to 402 divided by 10, I could say MPG is equal to miles, whatever they happen to be, divided by gallons, whatever that happens to be. For our tilt switch, we're going to need one variable. The variable is going to represent whether or not our board is tilted or if it's flat. And because of that, it's going to hold one single number. It's going to be a 0 off or a 1 on. In this case, if it's on, that means the board is tilted. If it's off or 0, that means the board is not tilted. Since 0 and 1 don't require decimal places, we will use an integer. Because the variable represents whether or not the board is tilted, we'll go ahead and name it something that makes sense to us, which is tilt. You can name your variables things that make sense, or you could just call it x, y, z. The problem is that if you come back to your program later and it's a very large program, that you might not remember what x, y, and z stand for. So it's a good idea to name your variables something that will make sense to you later if you come back to it a year down the road after you've built it. Once we have variables, we can use those variables to make decisions. And the if structure is something that we do all the time in our everyday lives. You say things like, if there's not time to cook dinner tonight, we will go out to McDonald's for supper. What happens is you have the word if that says, here comes a decision. You have a condition, we don't have time to cook dinner. And then you have what happens if the condition is true. In this case, we'll go out for supper. You can also have an extension to that which says, if the condition is true, we're going to do this, but if it's false, we're going to do this other thing. That would sound like, if we have time to cook, if we don't have time to cook supper, we will go out for dinner. Otherwise, we will cook spaghetti. In this case, you have the if, the condition, the thing that's going to happen if it's true, and the thing that's going to happen if it's not true. This can be expressed with a flow chart. Here we have our if, which is always a diamond. And then you have the condition. In this case, MPG is less than 15. Our statement here is going to say, if you're only getting 15 miles per gallon or less, you should go out and buy a different car to save money on gas. Otherwise, you should keep the car you have. And then in both cases, our program would go on to the next step, which would be the same next step whether we did the buy hybrid or keep car. For our tilt switch, our decision is going to look like this. If tilt, our variable, is 1, that means the board is tilted and we should turn the LED on. Otherwise, we should turn off the LED. If the LED is already turned off, it's okay to turn it off again. That won't hurt anything. But if the board was tilted and then it went flat, we would need to turn the LED off because we just turned it on. What does that look like in code? It's a little harder to read than the flow chart, but we'll walk through what this looks like. Here is some C code that would say if the tilt variable is equal to 1, then we're going to turn on the LED. Otherwise, we're going to turn off the LED. So it's the same expression that we had before with our flowchart, only it's written in C code. Let's walk through that code. First of all, we have the keyword if and a condition, and the condition is always inside a set of parentheses. The computer is expecting you to say if, and then inside the parentheses, here is what we're checking to see if it's true. Note that my condition says tilt equals 1. And in C and Java and a couple of other languages, the conditions always use equal to say, is it equal to? The double equal is confusing, but it's used because a single equal means take what's on the right, the expression or the value, and move it into the variable that's on the left. If I was to write this as if tilt equal 1 with one single equal here, it would actually set tilt equal to 1 and then mess up my whole program. So it's important to have the double equals. After we have the if and the condition, we next have a block of code, which could be 1 line or 50 lines or 1,000 lines, that say this is what's going to happen if the condition is true. Every block of code in Arduino C is surrounded by or bookended by these braces or curly braces, and that's there so you know it starts here, it ends there. So when I see these curly braces, I know that what's inside the curly braces is what's going to happen if tilt is equal to 1. And you can see after that we have the line that tells us, hey, go ahead and turn on digital pin 7, make it high, and we know that we're going to have our LED connected to digital pin 7, so that just turned on the LED. Optionally, meaning we don't have to do this, we could have an if that just stops with if tilt equals 1, digital right 7 high. But if we want to do something when it's not true, then we use this else keyword and another block of code. In this case, my else keyword is followed by a set of curly braces to tell me here's what's happening if the else is what's going on, and we're going to digital right pin 7 low, which will turn the LED off. In the next section, we'll go ahead and set up the breadboard to use the tilt switch, and then we'll modify our program so that it sees the tilt switch and tells the LED to go on or off if the board is tilted.